All right. So the purpose of today's class is just to give you an overview of some of the content that we've covered until now. We're not going to actually necessarily go into like the details on how to solve things, but the purpose really is just to remind you of this was a thing, remember when we did that thing, and here's how you can find the resource if you want to review it. Now, so today's Tuesday, we're doing the review. The exam itself is on Thursday. Next week, both class periods, we're not going to be meeting in this room. I'm going to be out of the country at a conference, and so the class meetings will be recorded videos that you'll just watch the YouTube lecture. There will be some sort of an in-class exercise that you'll need to complete and submit, so you'll upload that in the same way that you've had to upload and submit things in the past. So attendance credit will still apply because you'll be uploading some activity that I've introduced in the recording. But I think it'll be relatively straightforward. Our class is scheduled for 75 minutes, and those videos aren't going to be 75 minutes long because there will be portions where you should pause the video, do a certain thing on Excel, following along. And so the entire activity, I think, will take 75 minutes. If you pause the video and do the Excel part that I'm describing. But that's how we're going to do next week. Any questions about that? So here's the tricky thing, is that homework number 5 is related to those two lectures. And so essentially, you're going to have an entire assignment where we don't meet in class. There will be a Tuesday lecture, which is a video, a Thursday lecture, which is a video, and then the following Tuesday, you'll submit homework 5 online. Now, it's not particularly difficult assignment, but I just wanted to point out that's a little bit different because in the past, we've been able to interact with each other one-on-one if you've had questions related to the homework. I'll be able to access email while I'm away, although I'm going to be 9 time zones ahead of here, so my reply may be a little bit strange as far as the hours of it. So any questions related to the scheduling of things? All right. Well, I'll send emails with the links of those class videos, and also the links are going to be posted on MU Online. And I think this is a good point for me to remind you of how you can get all the lecture recordings because those are available for you to review at any time. For example, before an exam. So if you click here, here's our class, Engineering 111. Section 203. If you click on class lecture videos, we've had so far 12 lectures, and there's videos for each one of them. More recently, I've started identifying what the topic was for each class. So if there's a certain thing that you feel like you're a little bit weaker on, for example, if you're not certain on how to do the linear interpolation, maybe it would be a good idea to go back and review that portion of the class video. Or if you wanted to review how to solve quadratic and cubic equations or how to prepare a table on the calculator, here's the lecture for that. All you do, click on the link and it'll immediately load the YouTube video. So it's really straightforward. Any questions about the recordings? All right. So the exam is closed notes. And I'm going to temporarily disable most of our course web page during the video or during the lecture, so you couldn't watch one of the videos during the test. I guess that's the only time I would rather that you not watch those videos is during the exam itself. I'll provide any formulas that you need, including the formula for linear interpolation, so you don't need to prepare any kind of an equation sheet. And also, I would provide that same conversions sheet that I've given you before, the SI to traditional units conversions. So that will be provided. There are things that you should memorize, though, and we'll talk about that in just a minute. The exam will start right at 11 o'clock, and I don't think people will necessarily need every last minute of that 75 minutes, but you might as well give yourself the option. So I'd encourage you to be here on time. And it covers lectures 1 through 12, and all of those have corresponding recordings that are posted online. Please feel free to interject at any point if you've got questions about what we're talking on. Okay, so it's two parts. I'll actually print out two different sections. At first, I'm going to give you the portion of the exam that has to do with the basic engineering solutions and the Casio operations. That's part one. It's between 8 and 10 questions, and you can use only the Casio calculator and a writing instrument. And it's a suggested time limit of about 45 minutes maximum on that. And the reason why I've given you that as a suggestion is just so you preserve enough time for the Excel part of the test so that you don't fall behind. So after you complete part one, you'll bring it up, set it on the chair, and you can take part two, which is related to the computer. And on the computer, there is going to be questions related to creating charts, questions related to anchoring, you know, the absolute and relative cell references, goal seek, solver, being able to put in the best fit line, you know, creating an equation of best fit line. And what will happen is you'll download a beginning file from MU Online in the same way that we've done for some of the in-class exercises. Like it has certain cells where you're supposed to do the calculations. You actually type in formulas, create a chart in a certain spot, and then you upload the modified version of that file back into MU Online, submitting it for the exam. So if you spend 45 minutes on pencil and paper calculations, then that'll give you 30 minutes for the Excel portion of the exam. But the exam is designed so that I think the student who is comfortable with the material will be able to finish it in 45 minutes or even less. So it's intentional that there should be an excess of time.
On the pencil and paper, like that portion,
yeah.
Will we have to write it out like we do our homework? Or?
Good question. You're not going to have to restate the problem. You won't necessarily have to do a sketch. So it's not going to be exactly like the expectations on a homework assignment, but I will encourage you to show all of your work. And so if you can demonstrate intermediate steps and what your thinking was, then it's sort of like an insurance policy for you. Because let's say that you make some small mistake and you get the final answer wrong. If all you wrote was the final answer, you know, 39, with no supporting calculations or intermediate steps, then you get no partial credit. But if you can sort of demonstrate what your rationale was and what was the thinking, then you can get the majority of those points that are available, even if you get the answer wrong, just by sort of showing your workflow. So does that answer your question? Okay. I'm glad you asked that question because I can't emphasize enough how important it is to show your work. It takes a little bit longer, you know, 2 or 3 minutes over the course of an exam. But students who just get into a rush and aren't being kind of linear and logical in the way that they solve things and showing all of the work can really lose out on a lot of points. Okay, so here are some of the subjects that we've covered so far this semester. You'll remember that we discussed briefly those engineering prefixes, and there's a lot more of them than you actually need to learn. The ones that you should memorize are Terra through Pico. And I don't know whether you want to make yourself flashcards or maybe you already knew them, but there will be a question related to engineering prefixes. Included on the homework already, you've had plenty of experience with order of magnitude estimates, and so there may be questions related to any one of these subjects. For example, scientific notation. And now we're not yet talking about the calculator. These are types of problems that you maybe could use a calculator to do, but it's more about understanding what is order of magnitude and how to interpret scientific notation and switch between standard notation and scientific notation. Appropriate communication of significant figures. So for example, if you're adding and subtracting numbers together, then it would be the last common digit that should be reported. So remember, if we had 10.24 and 11.93872114, Well, all of these extra digits become extraneous when you add them together. When you add them together, then you're going to have your number be only to 2 decimal points, 2 digits after the decimal point. So there are similar things when it comes to multiplication and division. Whatever number has the least number of digits is how you're going to report the answer in the end. And so if you have a number with 5 digits multiplied by a number with 3, then your final answer should be reported to 3 digits. Expressing an answer in appropriate units means that sometimes an answer only makes sense if you say what the units are along with it. And so you could be reporting the weight of something in pounds or thousands of pounds. And in the previous slab, the slab weight calculations we did, that was referred to as kips. Likewise, unit conversions is important, being able to go between feet and meters, being able to go between pounds and newtons, and so on. And the handout to do unit conversions would be provided if there is a question related to that. And then linear interpolation is something that we did a problem together on the different day than we actually had it as a lecture, because it was something I feel like is really important, and I wanted to reinforce that to you. You'll be doing linear interpolation a lot, regardless of what engineering discipline you're in. And so if that's something that you feel confident about already, maybe you don't need to practice it again. But if it feels a little uncertain, then it's a good idea to remind yourself how to do those linear interpolation calculations. And finally, we haven't got into the programming part of the course yet, but we did talk about how to interpret flowcharts and the idea of pseudocode. So that would be also considered as fair game for the exam. So this is one of the 3 topics that are included on the exam, the fundamentals. And this is, any questions related to this would be on part 1 of the exam, which is before you get to use the computer. All right. So definitely bring your calculator on the day of the exam, because it's designed to test your ability to do basic calculations like just addition, subtraction, multiplication, division, and so on. Converting between rectangular and polar coordinates, degrees, minutes, seconds. And you may remember that for degrees, minutes, seconds, there's also a function to convert between decimal degrees. It's built right, it's just a button on the calculator, whereas if the answer is in degrees, minutes, seconds, then you can push that decimal degrees button and it will switch between the two. There are certain times when you could get kind of worn out typing in the same calculations over and over again. And so what the calc mode allows you to do is type in an equation. For example, you could say 3a plus b as a function. And then in the calc mode, just over and over again, it would ask what is a, what is b, and then it will do the operation for you. So that was the calc mode. Now the solve mode was a little bit more powerful, because in the solve mode what you were doing is you were actually entering an equation, both sides of an equation. And so in that, the solve mode, remember it's a little bit tricky to type in equations because of the need to use the alpha key. And let's pull up the emulator. Because as I was just looking at the emulator again, I reminded myself of one of the tricky things of using the calculator is you'll notice that there's 2 equal signs here. There's an equal sign in red, and then there's the equal sign here at the bottom right of the calculator. And when you're typing in equations to use the solve mode, you have to use alpha calc in order to type that equal sign to let it know that the equals is actually part of the expression you're typing rather than a statement that you want it to start solving something. And so just one reminder / hint there is that the red equal sign is what you use for typing in equations. And then the calculator also has the mode 5, which is where we went to solve 2x2 equations, 3x3, quadratic, cubic. And then mode 7 is where you can, for a certain step increment and a certain range, have it determine the values of a function in order to plot. And it won't actually do the plot for you, but it will generate the tabular data that you could copy down into tabular form, and then you could graph it manually. Is this ringing a bell? Do you remember all these sorts of things? I hope that you've kept notes, and there have been a couple of in-class exercises. Now, some of those in-class exercises you've uploaded to MU Online, and other ones were paper that I took with me. I've put those in the box that's outside my office door. So if you want to have those in-class exercises back as a study resource, you can just come to my office, which is in the engineering lab building. It's the smaller building next to this one. And I'm in room 113, which is the first office on the right as you start to walk in the hallway. So you can get your old in-class exercises. I think there are maybe 2 or 3 that have been on paper that I've put out into the box there. Okay, so the third and final topic, besides the general engineering knowledge, the calculator. Okay, so the third topic, which is Excel, that's the one that's going to be on the second part of the exam, where you can turn on your computer, download the seed file, and start doing interaction with it. So one of the tricky things with Excel, of course, is understanding what order it's going to do certain calculations in. And actually that could be a paper problem, not just a computer problem. Like if I gave you the function, equals 3 plus 1 divided by 2 to the power of 5 plus 7 divided by 9, you'd need to sort of think about what order does Excel do its calculations in. And remember that parentheses can be used to force Excel to do calculations in a different order than it normally would. So order of operations is a really important part that, a question like that could be asked on the actual interactive Excel part of the exam, or it could be asked on paper just to make sure that you understand how to interpret the way that it reads equations. Relative addressing and absolute addressing. Absolute addressing is anchoring, where you're using the $ to either lock the column, the row, or both. And so you've had paper questions on your homework where a table of numbers was given along with a formula, and then it asked you if, for example, just the row was locked and then it was dragged down and to the right, what would be the new updated number, or if the column was locked, and so on. Relative addressing is very useful if you want to do a calculation lots of times. You don't want to have to type it in over and over again. Generating charts and formatting them appropriately. For example, putting in the axis title and putting in a, being able to change the range of values that are displayed on the x-axis and the y-axis. Formatting charts, like removing the grid lines if you don't want them to be there. Curve fitting is where you right-click on the data points and then you tell it to insert a best fit line, and trying to determine with the r-squared value of which approach, whether it's linear, polynomial, logarithm, like which approach fits the data the best. And so being able to display that equation, and then if necessary, use the equation to predict a value at some point in between the data points that are known. And what I mean by that is, let's say that you had some data that looked like this. And so there's definitely a trend, and we could put a line through that data. But what if you wanted to know, you've got these two data points here and here. But what if you wanted to know what should the data be between those two data points? So you would use the equation that it gives you, y equals mx plus b. You would substitute in some x value and use the equation that it gives to predict a y value. And that's another skill that you practiced on the homework assignments. Goal seek and solver is what we did in order to prevent having to type things in over and over again. And so it's another time-saving feature. And does anybody remember what are some of the differences between goal seek and solver? How do you distinguish between the two? Okay, good point. So one of the differences is that solver gives us the flexibility to control when it converges. Like, we can make it more precise if we need to. Right. There's the constraints. So we can add constraints like forcing some aspect of the solution to be higher than a number, some aspect to be lower. Remember when there was the in-class exercise we did related to the shipping. You know, there's only 50 that can go from one of their warehouses. Yes?
And also you can control different variables to get flexibility.
Mm-hmm.
Goal seek is typically using one row or column to determine another row.
That's right. Yeah, one cell to have another output. I guess probably the biggest difference between the two is that in goal seek, you have to know the answer you're trying to get. Whereas solver allows you to say, I don't know what the answer is supposed to be, but I want the biggest one possible. So for example, max. So if you wanted to maximize your profit, then you don't know what your maximum profit possibility is before you start the iterations. But solver will go for a maximum, a minimum, whereas goal seek, you have to know an objective to begin the iterations. All right, so that's a quick overview. We have plenty of time where I could answer specific questions, but I don't want to keep anybody here if you have other things that you need to do, or if you feel like you're all set for the class. And so I'll bring the lights up, and just as a reminder, please be on time. Don't deny yourself any of the time that you could possibly have. Bring your calculator and your pencil, and I'll provide all the rest that you need. All right. So that's it for this. Any specific questions that I can address? Yeah.
If we were to choose between goal seek or solver, though, best is choose.
Yeah, there's never a time where solver won't be able to do something that goal seek can. Yeah.